On behalf of Department of AI, Anurag University, I, Tilottama Goswami, extend a very sincere, warm welcome to our distinguished speaker, Mr. Joy Mukherjee, Vice President, Enterprise Data Services at CareSource from Ohio, USA. I welcome Registrar and HOD, Department of AI, Professor Samin Fatima Ma'am, my fellow faculty members, beloved students, and all the participants present here on AI Industry Readiness Air 2021 series. The sole purpose of AIR monthly webinar series is to connect dots from classroom to industry. Industry interaction with institute gives students an insight into the regular internal workings of a company. It is a known fact that just theoretical knowledge is not enough for making a professional career. Industry institute interactions go beyond academics, and it is excellent exposure for students to attain practical perspective of the world of work. Students get an opportunity to learn practically by applying their theoretical knowledge through working methods, interactions, and employment practices. It gives them the exposure to current working methods as opposed to just classroom knowledge. Furthermore, the students are also able to learn about the work environment of companies and feel more confident when it is time for them to appear for campus interviews. I now invite Professor Samin Fatima ma'am for presenting the opening remarks of today's session. Ma'am, please. Thank you.
Ma'am, you are on mute, ma'am.
Thank you, Dr. Tilotama, for organizing such a wonderful series of webinars. You already had one, and this is the second one in the series. I think you're doing a great job. Uh, I am also very, very happy and thankful to Joy for coming here on this webinar and then talking to our students. Uh, as I'm told, we are having the second and third year students participating in this webinar. Uh, and my second year students would have just finished the first year and have been exposed to a little bit of programming. And second year students who are going to third year have some few core courses in computer science. But they still need to know a lot about data and databases and things like that. So I wish to just give a little bit of introduction to my students from their perspective. I think the faculty and other people are all well aware of what we are talking about. But for the students, let me take a small example to start off. I am a lady and I normally entertain guests at home. So the first thing we do is when guests come, we offer tea. And I'm very good at preparing tea. So how do I go about making tea? I think the boys, do you know how to make tea? Not sure. Okay. Maybe the girls know how to make? Not sure. Okay. Well, so girls, boys these days, I mean, they're not so good at making tea, but we people from so many days we've been making tea and we are good at it. What do we do to make good tea? We have to get some ingredients. What are the ingredients we get? Some tea powder, maybe a good brand, some water, some milk, and some sugar. These are the ingredients. Now, when I start making tea, it looks very simple. The ingredients are very simple. Water, tea powder, milk, sugar. But when you're adding all of this, sometimes people add more milk, excessive milk, and then the tea doesn't taste like tea. So we cannot add something which is more, which is excessive. The same thing holds true of data. If data is redundant or it is excessive, we should remove that data. We don't need that kind of data. So as much of data that is required, we should have only that much data. Just like the milk that we are adding to the tea. If we are adding more tea leaves to the tea once again becomes bitter. So that's not a good option. So you don't need to have more tea powder. You have to have it in the right amount. Now, what you do, you start boiling the water, you add the tea powder, and you let it boil. Then, after some time, you add the milk to the whole mix. After finishing boiling for some time, let it steam for some time, and then you start straining this tea. What do you do while straining the tea? The tea leaves have left the aroma, have left the color, okay, in the water. And this tea leaves have to be removed. We can't serve the tea leaves to the people. So we have to remove the tea leaves from this tea that's getting made. So what happened? The tea leaves got transformed. The tea leaves got transformed into a liquid where they left their aroma and they got transformed into some kind of a color, a nice tea color. And this is what is being consumed by the person, not the tea leaves. So there's a transformation of tea leaves into aroma and color. Then what happened? The next thing we do is, okay, this is all done. I have to add a little bit of sugar, again in the right quantity, and put it all together and make it ready to serve. When I want to serve the tea, what do? I use a teacup. And a teacup, if I have a teacup which is having stains on it, or it is discolored, or its handle is broken, and if I'm going to serve tea in that, although my tea is very good, it is piping hot, yet if I serve the tea in a cup which is not looking good, which is not having uh, a handle, or it's discolored, or it's having a stain on it, the person who is offered the tea will not drink the tea, although the tea is made very well. If it is not presented properly, it is not going to be accepted. So if something is broken, if your data is not enough, supposing you are looking for a date of birth and you just give me date and you give me the month, you don't give me the year. The data is broken. You don't have enough data. And then this also creates a problem. Nobody is going to consume that tea. So it's a very simple example, but I think this regular process of making tea is just like your data preparation. You try to prepare your data before it can be consumed, before somebody can use it. So that's very important. And most of our jobs today, 80% of them are in this sector, where you prepare data, you clean data, you transform data, you make it amenable for further analysis and further processing. So my dear students, I just wanted to give you this introduction, but I think Joy is here, and Joy will take you through the joyful technologies which are available to make this possible. Thank you very much. God bless you.
Thank you, ma'am. Thank you for the wonderful example, real time example. And now I would request Tejasvi to introduce today's eminent speaker. Tejasvi, over to you.
Yes, ma'am. Good evening, everyone. I feel privileged to introduce you all to our distinguished guest of the today's webinar, Mr. Joy Mukherjee. He leads enterprise data services at CareSource, a non-profit multi-state health plan recognized as a national leader in managed care. He is responsible for the strategy, design, development, and implementation of enterprise data solutions to meet the needs of the business. His role includes collaborating with multiple business functions to ensure that reliable, governed, and optimized data is available across the organization. Joy has extensive experience working with data and application in the healthcare domain. Prior to CareSource, he worked for Blue Cross Blue Shields of Massachusetts as the Vice President, Core Application Delivery, responsible for data solutions as well as core operational systems. He has held multiple leadership positions in data and business intelligence for over 20 years. Joy earned his bachelor's degree in computer engineering from Manipal Institute of Technology, India, and an MBA in finance from University of Massachusetts Lowell. He is also an America's Health Insurance Plan certified health insurance executive. Now, I hand over the session to Mr. Joy Mukherjee. We shall take the questions from the participants at the end of the session. My friends Charanya and Rahul will assist in coordinating the questions. So, please.
Thank you for that introduction, and thank you, Dr. Fatima and Dr. Goswami, for setting the context around that example. So before I actually start, right, I'll double down on Dr. Fatima's example of making tea. One thing that I'll add is the person who drinks the tea enjoys the tea. They don't always realize the amount of effort that Dr. Fatima put in to make that tea very good. And that's true of data. When you actually consume the data, people will kind of appreciate the quality of information that you put out there, but they don't always realize how much effort went into that. That's where the IT professionals behind the scenes do the hard work there. So let me start off by sharing my slide deck. And Karthik, let me know if everything is fine.
Yes, sir.
Okay, I'm going to put it in presentation mode so that you can see it nicely. Okay, I have lost your images, but I'll talk through it, and then when we have questions, we can kind of switch back and forth. Um, I actually wanted to start off with an example very similar to what Dr. Fatima gave you. So, I mean, one of the things that I like to do is put things in context of real life, right? That tea example is a very good example. So if you take nothing away from this presentation, remember that tea example, because it is very relevant to how the data world works. So I actually wanted to start off with a similar type of situation, right? So what you see in front of me is not an advertisement. I do not work for this company or try to cross sell this, right? What you have on the screen is a machine called the Roti-Matic. It makes rotis, automated application that makes nice, warm, perfectly round, perfectly flaky rotis, and all you have to do is put ingredients in there. The language around the marketing of this talks about powered by artificial intelligence and IoT capabilities. So what I personally don't own this machine. I have never used this machine, but I do know colleagues of mine who have it in their homes, have used it for over 4 years, and they use it on a regular basis. So it is actually a machine that works, right? So think about it. It's a very simple task, right? I mean, I would bet that most of you have some form of roti or bread or paratha in your meals at some point. And here's a machine that's using AI to make your rotis better. So it needs the dough real time for each individual roti separately, ensures that every roti is perfectly round, perfectly flaky, and the same size as the previous one. And it the feature that the company touts is it's learning by itself. So as you probably guessed, right, there is quite a bit of intelligence in this machine. So it's not just a roti maker; it's also a computer. It has likely some Linux-based operating system in there that's reading data, processing data, and producing the rotis, right? It's also Wi-Fi connected, so you can from your workplace driving home, you can say, okay, start my roti making, so that by the time I get home, I will have a stack of rotis, nice and warm, to have my meal. But guess what? If this machine can only do its job the way it's marketed to do its job if the quality of the ingredients were strictly followed in terms of the requirements. So essentially, nice clean water, the consistency of the atta that goes in there is all predefined. If you mess up with that, no amount of artificial intelligence will correct for it. Maybe that's overstating it. Maybe it can compensate for some minor problems, but if you don't put a little bit of oil, you don't put the correct clean water in there, you will not get the output product. So data is very similar to that, and that's why I wanted to spend this webinar talking to you about what happens with data preparation and why it's important in what you do in the real world. So moving on to my agenda. So I'll kind of interweave some additional items into my presentation that Dr. Goswami and myself discussed that might be beneficial for you as students to learn about that, right? So I'll talk about the data flow architecture, what's traditionally been the process, and then subsequently what it's going to look like in the future. And some of that, when I say future, it's already happening. So I'll touch on that. Um, I'll double down on that garbage in, garbage out principle, the cost of bad data. I'll touch briefly on structured, semi-structured, and unstructured information. I know the semi-structured and unstructured is more prevalent in the literature that you see in the real world today. I'll give you some real world perspectives on how easy or how difficult it is and how important it is. Data processing technologies, I will touch upon how the industry has evolved from the traditional RDBMS or database management system architectures and what it's going towards. I'll also touch upon things that are not necessarily hardcore technical or engineering aspects of it, the importance of understanding your data. And then interoperability of data, I'm going to give you a context of why, what the industry is going towards in terms of data ownership, data movement, the ability to seamlessly share information between applications, between industries, and so on and so forth. The other topics are data privacy challenges. So I want to talk about data privacy because I'm in the healthcare space. I have been in the healthcare space for over 20 years now. It's a very, very important, strictly governed by the central government kind of approach to privacy. Then I want to touch briefly on data science. I bet you guys know more about data science than I do, but I'll give you some examples of healthcare applications, what's happening in the industry today. And finally, I'll close out with careers in data. What type of roles is the industry looking for at this point in time, and then what would help prepare you for the real world as you step out and complete your courses and start your jobs and career. All right, so this is the traditional data flow on a back-end system of most organizations. So essentially, organizations have operational systems that generate data. There are external sources that generate data, and then you bring in reference data. This is not an all-inclusive. There may be other things, but it generally captures what comes into a company in terms of data. You'll notice that most of this, or if not all of it, is structured data extracts, very, very batch-oriented in the sense that on a nightly basis, a data dump is created from an operational system. It's a very structured format data. It's ingested into a staging area. You'll notice that I use the database icon to represent this because most of our traditional environments are Oracle DB2, the traditional databases, Netezza, Teradata, and so on and so forth. So typically the flow of information is you stage the data, you apply a lot of business logic on top of it, some amount of cleaning and structuring, and then you present the data in a consumable format. And then once you present the data in the consumable format, the data engineering aspects of it is more or less done, except unless you include reporting, business intelligence, and extracts, and the ability to run data science algorithms on top of that data. So this has been the flow of information for years. It's served the industries well, and a lot of organizations are still doing it this way because it's matured over time. The technologies are robust. There are appliances that have been built this whole thing together. So it's by no means something that's not in the industry today. I just wanted to put it out there because this is what you'll see most commonly in a legacy organization. So moving on to what's next, right? And what are organizations tinkering with? So and you'll notice that I did not use the label enterprise data warehouse anymore. In the previous slide, I called it an EDW. What's generally happening in the industry is people are moving away from calling things EDW because it has that batch nightly or monthly construct to it, that it's refreshed on a monthly basis, and then subsequently the data lags the business needs and so on and so forth. So what's happening now is we're moving towards what people call a data platform. So it does all things data. Near real time, if not real time. So the same sources of information, the operational system, external sources, reference data, all coming in, are now coming in a continuous stream. So what I mean by that is it's using technologies like Kafka, kind of generate data on a near real time basis for downstream consumption. So similar to the staged, transformed, and consumable layers that you saw in the prior slide, there is acquired, parsed, integrated, and consumable. So I'll quickly touch upon what these layers of data processing really mean, right? So acquired, think of it as received data. So if I received an XML file through a continuous stream, or an X12 file, or a JSON file, I'm storing that in its raw form. In the parsed layer, is very light transformation done on the data. Example would be standardizing date formats and making sure that it is in a DDMMYY format. Standardizing all text to be uppercase. Standardizing things like removing all non-ASCII characters or characters that might cause problems in analysis downstream. For example, commas. Commas are notorious for causing issues in database technologies. And then the biggest lift in the process is integrated layer. This is where the bulk of what you saw in the prior slide as transformations, transformed, happens. So you structure the data into tables, into tables that relate to each other. And then finally, when you get to the last layer, integrated layer now is at a state where an advanced data user can start to use it. Not everybody is an advanced data user. So you have to think about all the different consumers of information. And then that's why the consumable or consumption layer kind of comes into play. In that consumption layer, what's really happening is you're simplifying the structures of data. So as you understand modeling, you will understand the concept, or you may already know the concept of star schemas and facts and dimensions. And that's what the consumable layer looks like. It's easy to use, simple to understand, and an entry-level data analyst can easily kind of produce reports or do analysis on consumption layer. You'll also notice that I displaced all the consumption side of things. So I put business intelligence over the integrated layer and consumption layer. So now business intelligence has the ability to go back to an earlier version of data if needed. And then the data science aspect of it is the other big difference here. Data science now has access to data in all the layers, not just the consumption end state layer. There are different reasons for that. Sometimes you need it in the raw form. Some of the transformations in the data may have disrupted the way you approach your algorithm. So and on the right hand side, you'll notice that I left the reporting side of it. Reporting will never go away from the industry because the executives always want some reports on data and dashboards and so on and so forth. But for all downstream systems that want to consume information, you're again putting it out into streams. So basically, technologies like Kafka, like REST APIs are becoming more prevalent on the consumption side of data. Obviously, there will always be some element of self-service. So essentially, open up a SQL query tool like Toad or SQL Server Management Studio, and you actually query tables and objects in there. The other nuance in here is traditional tabular structures versus file-based structures. And I'll touch upon that in future slides, because it's all mushed into one. In the old technologies, you would always see tables with rows and columns and stuff. Here, you actually have to deal with raw files. So files in the Parquet format, files in JSON format. All of these are now queryable using languages like SQL. So the traditional structured query language, I would say make sure you are an expert in SQL, because SQL will never go away, no matter what the backend data format is, no matter what the structure of data is. Because it's such a powerful language, it's been retrofitted to be able to consume any format data. So I'm going to speed up a little bit. I took up quite a bit of time on the first two slides. So garbage in, garbage out. I bet you've heard that term, garbage in, garbage out. So essentially go back to our T example of our rotomatic example. What you put in is what you get out. And that's true in data as well as in life. The amount of effort you put in is always shows on your outcomes. So why is this such a big deal, right? So first thing you have to remember is operational systems that generate most of the data were never designed for data quality. They were never ever traditionally designed to produce quality data for downstream consumption. They were designed to process transactions. So think of a banking application. Think of in the healthcare world, the claims processing application. They were all designed to move money from A to B, or apply interest rates, apply you can think of stock investments and all of that stuff. They were all designed to do transactions. And if the process of doing a transaction requires you to skip a data quality step, by all means, they'll do it. So what happens in the end? When you create an output out of that system, you have gaps in the data quality. Why hasn't this been solved yet? So it requires investment. So that goes into my second bullet point here. It requires operational rigor. So think of it like somebody who's running data operations or on a day-to-day basis, receiving, let's take the example of a call center about his bank account not reflecting the right balance, right? So they are putting in this data as you're talking to them into these screens, right? And then maybe they ask me, oh, can you give me your account number? And I say, I don't have the account number readily available, but I can give you my member number and stuff like that. So what do? They skip the account number data element and then just move on, because the system allows them to do that. And it's designed for customer service. So if imagine if they were to stop and say, hey, I can't do anything, Joy, until you get me the account number, it would be a poor customer experience for me. So that's why some of the data quality in the source systems tend to have gaps in there. The third bullet point is what I want you to take away from this, right? Impact becomes progressively bigger as the data moves through backend systems. So there is a principle called 1-10-100. What it essentially means is cost of preventing an issue is $1, cost of correcting it is $10, cost of failure is $100. So as you can see, as data moves through the system, it gets progressively much more expensive. In fact, in this particular rule, it's 10 times more expensive to fix data as you go through the system. So me as a data professional, I would argue that, hey, fix the operational system so that I don't get bad data coming out of the back, because fixing it at the back end, or even fixing it after you've run an algorithm, a machine learning algorithm, is even more catastrophic. So let's, I mean, think of what can happen, right, if you have poor quality data. And I'll take the example of running predictive modeling kind of algorithms in the healthcare space. So if you have bad data, so just a step back, predictive algorithms in healthcare, what they do is analyze health data, so lab results, how many times you're going to the doctor, what was the doctor's diagnosis, and so on and so forth. And they try to predict what's going to happen with your health next. Is Joy going to become diabetic in 6 months? Is Joy likely to have a cardiovascular incident in 1 year? And these technologies, trust me, are getting more and more accurate as these algorithms are getting tighter and tighter. So if I have bad data and I predict that Joy is becoming diabetic, and I'm going to prompt, I'm going to do an outreach to Joy saying that, hey, Joy, we need to manage your sugar intake or your exercise level to prevent this from happening, right? I'm essentially making Joy do something that is not fundamentally accurate. And as you progress through the ecosystem, it becomes more and more impactful. My last point is, because I'm a data guy at the back end, I always think the solution is simple: fix it in the front end. The front end guys will say, sorry, we can't do it. It's a customer issue. All right, so let me move on to this. What can you do to kind of, even at the acquired layer? Think of the visual that I shared with you earlier. The acquired layer is where you're receiving data. Parsed layer is where you're likely transforming data. What I have in front of you is the output of a tool called Informatica Data Quality, IDQ. It's a product from a company called Informatica. You're probably familiar with them. But my point is not to tout the capabilities of that tool. My point here is showing you that data profiling is a relatively easy task to do. And you should get into a rigor of, when you're receiving a new data set, I want to profile that data set. I want to run simple analysis on it. How many unique values am I getting for each attribute? How many nulls am I getting? What percentage of the data is nulls? What is an inferred data type? Even before any kind of modeling or stuff, like this data is marked as an integer in the documentation, but it looks like more like maybe it's a character field, or it's a character field but it always has numbers. So you can do these kind of things. You don't need to invest a lot of money to buy a tool, or a company does not need to invest a lot of tool to buy an expensive data profiling tool. These are relatively easy, low-hanging fruit that you can do to make sure the data that is coming in, you have a very strong understanding of the quality of the information that's coming in. So easy thing to do, often overlooked because people want to rush to process the data and make it available for consumption. All right. Structured, unstructured, and semi-structured data. So, I mean, this slide is largely theoretical, but it kind of gives you a view of what would you, I mean, if you were to line things up and say that, hey, should I work with structured data or unstructured or semi-structured, or what will I see in the industry? Yes, traditionally you would largely see structured information. It was organized in rows and columns, like I talked about. You can get a file layout document that tells you exactly what's in the file. You can group things together and say, oh, these 20 attributes define my customer's demographics data: his name, age, address, phone number, cell phone, mobile number, whatever else, things like that, right? It's easy to store and analyze and search because you can ingest it into a traditional DBMS, RDBMS table and analyze it. and you always use SQL. And I can't tout SQL enough. I know I said this before, but trust me, SQL is a very, very powerful language. If you really become an expert in SQL, there is a lot you can do with SQL. Unstructured. So let me set the context around unstructured information, right? So what you probably hear in the industry that a lot of the data is transitioning to unstructured. Why is that happening? It's not like unstructured data never existed before. We always had imaging, for example, right? You always had X-rays, CT scans, and music files. You always had other data that was not traditionally in rows and columns and structure. But what happened in the past is we did not have the computing power to be able to manage this data or you extract intelligence out of that data. Now we do. So that's the biggest difference that's happened over the last few years. Is computing power has gotten to a level where, I mean, you guys had a cloud technology webinar prior to this one. It's almost theoretically infinite amount of processing capacity. If you're willing to pay for it, you can get whatever you want. You can get a big honking server to process any workload. So unstructured data is making its presence because of computing power advances. And like think the best example is images. Unstructured data is images. Images is a very easy example to think about it. It's not associated with any data model structure. Yes, if I were to take pictures off of your mobile phone, it has some metadata associated with it. But I mean, the actual picture itself is not structured in a data model perspective. You need advanced processing, but like I said, now you can do it, and has traditionally been ignored because of difficulty of use. I touched upon that. It's commonly managed in files and data lake technologies, and I'll touch upon data lake technologies in one of the future slides as well. Semi-structured. It's by the name itself, you can imply that it's somewhere in between structured and unstructured. So it has some defining characteristics, but it's still largely unstructured within those bounds. So semantic text make it easier to organize. I gave you the example of on your mobile phone, you probably have hundreds and thousands of pictures, right? If I were to extract those pictures and look at the metadata behind those pictures, it does have quite a bit of metadata. So, for example, it tells me what type of phone, what type of camera lenses on the phone, where that picture was taken, what resolution was it taken at, and a whole bunch of things like that. But the picture itself is unstructured, but all that metadata around it creates somewhat of a semi-structured field. Other examples of semi-structured data, JSON is a format that's catching on. Some people would argue it's a structured format. I argue that it's a semi-structured format because there's a lot of flexibility within the JSON structures that you can work with. Parquet files and a whole bunch of Avro files. There are a lot of other things that are coming into the industry that are finding the sweet spot between structured and unstructured. So if I were to put a finger on what you would see most as you get into the industry, I would say semi-structured is probably it. All right. So moving on, I'm keeping an eye on the clock. This one, make sure I leave enough time for you guys to ask questions. Data processing technologies. So I know when I went to college, we learned traditional RDBMS, traditional operating systems, traditional networking infrastructure, and so on and so forth, right? Is that all obsolete? No, it's not obsolete. So let me set the context straight, right? Do I use the traditional networking knowledge that I acquired in college on a day-to-day basis? No, I don't. But that created the fundamentals for me to be able to understand and transition over to the newer technologies. By all means, if you do not have that foundational knowledge, it is very difficult for you to start with an AWS platform and learn everything in AWS platform, for example. Can it be done? Yes, it can be done. But when you hit the wall against some technical challenges, you'll find it difficult if you do not have those fundamental understanding of how things work. Growing up, I was fascinated by Linux and Unix and Solaris and so on and so forth. I spent a lot of time trying to become a systems administrator at one point in my career. Did I become one? No, I did not. I transitioned to data. But believe it or not, even today, I am able to talk the language with the SAs, the system administrators in my organization, because I have spent the effort to understand the fundamentals of how things work under the Linux engine. So similarly, on the data side, you need to understand that. I'm not going to go through all these technologies that you see on the screen. These slides, you will have access to it. Be familiar with what you see in there. When somebody talks about glue, what is glue, and what is it used for? What is Redshift? What is it used for? What is Elasticsearch? And you may already start be tinkering with all of these. S3 is one thing that you'll hear on, and what's the difference between Glacier and S3 and things like that. It's very important for you as you step into the industry to be familiar with it, even if you don't have hands-on experience with these technologies. I have a slide for AWS and I have a slide for Azure. I personally, at my current workplace, I'm working on a complete new implementation of our data platform on Azure. So I'm more familiar with the Azure stack, but the reason I put AWS and Azure in there is all of the services that these cloud providers are providing today, they are all kind of meeting the same type of needs. So you can draw a table and say, okay, for ETL, what do I use in Azure? And it'll say you use Azure Data Factory. You can use Databricks. And then what do I use in AWS? It is Glue and some other technologies. So there are parallels that you can draw across all cloud platforms. And I put AWS and Azure as examples. I did not put GCP because I'm not very familiar with GCP, Google Cloud Platform. But similarly, you'll find the same technologies in GCP as well. Moving on, and the other thing that I wanted to, and I've been touching on these things, right? They're file-based operating systems that are coming into the data space much more. Hadoop, I'm betting that you guys have probably tinkered with Hadoop or at least heard about Hadoop. Distributed file systems is making a significant impact in the data industry. So in the traditional world, back in the day, we used to rely on Oracle. Oracle has data files, Oracle has control files, and backend systems like that. Again, computing power was not at a level where you could actually treat a file as a data environment. Now you can. Distributed file systems, distributed processing, distributed programming technologies allow you to use file-based data in a much more efficient pattern than you could have in the past. Again, I'm not going to go through all of these technologies, but I just listed a few of them just for your reference. I've also put in a link in the slide deck. You can go, this is a very simplistic table where it gives you descriptions of what these technologies are doing and whether you should tinker with them and figure out all of this. The best thing about all of this is most of this stuff is open source free. So you could go and set up your own Cassandra instance. You could set up your own Impala interface and tinker with it and learn it by yourself if you're really interested in it. We are seeing a lot of companies actually delve into using technologies that you see on this slide. I have a few more slides, so hopefully I'll get through the end of it. So understanding data domains, and I talked about, this is actually non-technical in the sense that as you progress through your career, let's say you start your career and you're working in the banking industry or financial services industry. The classic first job will be, you will be deep in the weeds of technology. You'll be asked to build systems. You'll be asked to do some programming, backend, and all of that stuff. At that part in time in your career, you don't really care about what the end usage of that data is. But as you progress through your career, what you'll notice is you tend to draw towards a specialization. You will become like an expert in healthcare, expert in communication, expert in finance related technologies. As you progress through the career, understanding your data is of utmost importance. And I know a lot of the students that are listening to this are in the AI space, right? That becomes even more relevant. Understanding what data you're reading, how to interpret it, what are critical attributes, and how it's going to actually be used by the end consumer. So do keep an eye on it. If you don't understand your data, find somebody who does and ask a whole bunch of questions. That's what I did in my career. I kind of bugged people like crazy on the business side of things before I could get to a point where I could talk their language and I could understand healthcare. Healthcare is very complicated. So it took me a little bit of time, but I can't stress the importance of actually doing something like that. Interoperability of data. So what's happening especially in more of the advanced countries that are more structured in terms of how information is being shared. So the central government, the federal government, we call it in the US, has started to put out these rules saying that data must be available to the end consumer if it is about them. Think about it for a minute. So what we are facing right now in the healthcare industry is Joy can come to any company that deals with Joy's data and say, give me my data. I want to give it to Apple so that they can put it on my Apple Watch and give me my lab results in a nice interface in my Apple Watch. That is actually a federally mandated law. So what that means is increasingly companies are being forced to put data into shareable formats, standardize on protocols on how to exchange information. So standard formats like in the healthcare space, there's something called EDI, and electronic data exchange format. So they have standard numbers. So 837, for example, is a medical claim. 834 is an enrollment transaction. So these are all standards. So no matter who sends me an 837, it should look pretty much the same. I'm not saying it's a flat file. It's a version of XML called X12, but it is essentially leading to more democratization of and ownership of data. So sharing of data will become very important and more in the future. Bit of privacy challenges, and I'm almost up at time, so I just want to move forward a little bit quickly here. So as you deal with data, and especially this is important in the healthcare space, right? There are laws around what information you can share, how you can share it, and where you end up with violations. So we have to be very careful about what data we move and whether it's de-identified or not. De-identification of data is essentially, think of it like if I have Joy's medical claim record, right? And I want to share it with somebody who wants to do analysis on it. There are laws that says you have to mask Joy's personally identified information. So essentially, what does that mean? I have to change Joy's name to something else. I have to change Joy's birth date to something else. I might even have to change Joy's address and gender and phone number to something else. So flip some digits or kind of change the sequence of things, right? What does that do? If you're running a predictive algorithm and you change my birthday, that is a very impactful change on the algorithm itself, right? So all of a sudden now I look like I'm 78 years old and not 48 years old. My predictive algorithm is going to behave differently. So that's why I called out there are challenges with de-identification of data. We have to work through those challenges, right? The final point I'll make here is that we all know Google, Facebook, Amazon, whatever you use, WhatsApp, they collect tons of information from you. Just in today's world, to expect that any of these companies don't know you is just naive. They know everything about us. They know that at this point in time, I'm joining you guys for this presentation. They know a lot of different data about you. So just be aware. I mean, there's no getting away from it unless you completely unplug from a digital world. Data science. So some examples that I quickly wanted to highlight here. Data science, we all know the things about recommendation engines. For example, if you watch Netflix, right? Netflix looks at your history of what you watched on Netflix, which movies you've seen, and comes up with recommendations, right? That is a standard recommendation engine, and that is an application of data science. Other music streaming channels are also doing it, like Spotify and so on and so forth. But in the healthcare space, right, here are some examples, and I'm not going to go through this for lack of time, but you have your the deck available to you. You can reach out to me, and if you want to find out more information about what's happening, how is data science being applied in some of the healthcare spaces. And finally, I have careers in data. So this is I looked at my organization today and said, what capabilities does my organization have? And that led me to roles within my organization. So this data analysis, modeling, data engineering is where a lot of the technology folks are there. Data science is the same way as well. Operations is there. Support data services are also there, and BI and reporting. These are some examples. I'm not exhaustive by any means. So when you step out into the industry and start your jobs, right? It's not like you have to go and say, I want to be a data engineer. I want to stay with that track, because the reality of it is you will move between these roles in the early part of your career. But what typically tends to happen is, as you mature with your work experience, you'll stabilize to a particular point, and you'll start take a specialization in one or more tracks. And you might choose not to do data at all and do something completely different. But it's just something to be aware of. I think that essentially takes me to the end of my presentation. So I'm going to take it off of the presentation mode and give it back to Karthik for questions if you guys have any.
Thank you, Joy. It was wonderful session. The question answers will be coordinated by Sharanya, my student. Over to Sharanya.
Thank you, sir, for your wonderful speech. I have few questions from the audience, sir. Can I proceed?
Yep, let's go.
Thank you. Mention what are the differences between the data mining and the data analysis, sir.
The lines are being blurred between what traditionally was data mining and what is data analysis, right? Think of data mining as somewhere between profiling and extracting intelligence out of a random data set, right? Analysis is more of, you already have upfront information that this is like medical claims data, and you know that context around it. Data mining can be completely different there. Data mining can be like, here's a data set, I know nothing about this data, go do some discovery on this data, profile it, analyze it, and tell me what this data is telling. So that's a difference there. I apologize, my
Yes, thank you, sir. Then, which language do you prefer, either Python or R for analyzing the data?
I would say Python is the good language to start with. R gets into the statistical modeling side of it. Because I have AI students in the audience, I would encourage both Python and R. I'm in my organization today. We're using Scala quite a bit, because Scala is highly performant on the technology stack in Microsoft Azure that I'm working with. So Databricks is the tooling that we use. In Databricks, you can actually write code in Java, Python, SQL, or R. and you can switch between languages in data frames. So maybe what I mean by that is the technology allows you to first write first piece of code, let's say in Python, second piece of code in Scala, third piece of code in SQL, and it's all one notebook. So the question about languages is becoming, the lines again are getting blurred between what you stick to and do I have to lock into using only Python or R. But Python is also, in my mind, an easier technology to learn. And I would say it will become table stakes as you enter the industry. So essentially, everybody will be expected to have some understanding of Python, and like SQL was in the past.
Thank you, sir. What is mean by data cleansing and what are its uses?
So data cleansing is essentially, how best to put it? I talked about all poor quality data quality issue. Cleansing is kind of overcoming all of those drawbacks of data. You can think of cleansing as simple as, do I remove non-ASCII characters from a file set that I have received? That can be considered cleansing. You can also consider cleansing as, remember when I talked about lightly curated data in the parsed layer? That part also is data cleansing. So standardizing date formats to be DD, MM, YY is an example of lightweight transformation that we could also call cleansing.
Thank you, sir. Next, how do you handle missing data and what imputation techniques do you recommend?
So missing data, it's the bane of everybody's existence, right? So the way we approach it, and I touched upon it when I said data profiling, right? So when we are bringing in a new data set into our environment, what we tend to do is do a profiling exercise on that data, one time as well as on a regular basis. It's not like a one and done kind of thing, right? When we produce a data profile, right, it will show you where the gaps are. Like let's say there's a critical attribute in the data. Again, take our example of date. Let's say date of birth is one of the attributes that I'm expecting to receive in the data. And let's say 50% of the time, the data attribute that date of birth is empty, right? What I would do in that case is, it is such a critical data element for what I want to do for the future. I would stop there, go back to my producer of data and say, my quality of data that you're sending me is, I cannot work with it unless you fix this problem with it. So there's a lot of upfront profiling and back and forth with the data producing organization or the team or the system to see if I can eliminate the challenges. Moving forward with gaps in the data, you could do it. You could default date of birth to a particular date and just processing continues, right? But it will yield to incorrect results based on how complicated that gap is.
Thank you, sir. Next, what are the data validation methods that are used by the data analysis, sir?
So data validation. So essentially, what you will see in the industry is people create a framework around data validation. So basically, you have some standard rules from a technical perspective. Like I said, is it null? Is it not null? Is the date format correct? Is it, do I have non-ASCII characters and all of that? That's very technical stuff. But in the validation framework, we also import business rules. So we work with our business partners and say, can you tell me what rules do you want to implement in as I bring data into the environment? That, like, let's say the business has a rule that column A and column C must be relatable, right? And it is not technically, as an IT person, I don't necessarily know that rule, but the business person is always looks at those two attributes and says, if column A is populated, column C must always be populated. Those kind of rules we take from the business, implement it in the, I'll call it the ETL flow, and say that, okay, there's a data validation framework. I'm going to do these checks every time I ingest that data. If it fails, I'm going to kick out reports. I'm going to put records in quarantine. So if there are 100 records and 4 of them are bad, I put those 4 records in a quarantine area for further investigation so that it does not disrupt the processing downstream.
Thank you, sir. There is one last question. What are your top 5 predictions for the next 20 years in data technology?
Democratization of data. So essentially, people will own their own data. So, and I'm seeing it already in the healthcare space in the US. So think of it like this, right? Today, data is considered to be a very big asset for a company. So if I know more about my consumers, I can tailor my marketing towards them, and it's all secretive. That's what Facebook does. That's what Google does. That's what Amazon does. All of these big companies are creating profiles of you and me, and they know exactly that Joy is likely to make this purchase because Joy's friend Tilottama also made this purchase, and they must be talking to each other, or they exchange messages on WhatsApp that said that Tilottama bought something, and Joy might be interested in that as well, right? Um, they tightly guard this data because this is their bread and butter. This is what distinguishes them from any other organization. But in the future, you'll see more of democratization. So you'll have visibility into what Google has about it. Actually, you know what? You can do it today. You can make a request of Google that give me everything that you know about me. You can actually do it. It's a very complicated way to do it, but you can do it. So democratization of data is definitely one of the things that you'll see. Data technologies will continue to advance to a level where processing of data will become a non-event. So you don't have to worry about your algorithm running for 8 hours. It'll run in 8 minutes. It'll run in 8 seconds eventually. And no matter how large a volume of data you're processing, how complicated your logic is, processing power will continue to increase. There will also be a proliferation of cloud technology usage, just because cloud technology is where most software companies are putting their dollars behind building. The amount of investment that goes on, for example, even in Oracle for their cloud support, is far going to exceed the amount they invest in traditional on-premise technology. So these are some of the things that you'll see. I don't know if I counted 5 there, but I think in general, right, it'll feed off of I'll call it larger IT advancements. So what I mean by that is, in today's world, even in today's world, and what has been traditionally a data space is a specialization in data, right? And just simple example that I'll give is in my earlier slides, I talked about what is like the enterprise data warehouse. The term EDW is going away, right? Why is it going away? Because other technologies are kind of blending the lines between what used to be a traditional data domain in technology versus what used to be a data ingestion, data sharing, all that stuff. I talked about Kafka. Kafka is an integration technology. It is not a data technology, but it's making inroads into your data platform because the lines are getting blurred between what is traditionally a data domain technology versus something else.
Thank you, sir. It was very informative, and thank you for answering all those questions very patiently. I see there were no more questions from them, and it was very insightful session. And now I would like to invite my friend Sujita for proposing the vote of thanks.
Good evening, one and all. Learning is not attained by chance, it must be sought for with ardor and attended to with diligence. It is a moment of great privilege and honor for me to propose vote of thanks on behalf of the Department of AI, Anurag University, for the second session of the AIR 2021 webinar series. On behalf of Department of AI, Anurag University, I would like to thank our distinguished speaker, Mr. Joy Mukherjee, for enlightening us with his profound knowledge and experience. It gave us deep insights into the topic of data preparation for advanced analysis and also revealed some interesting facts. I am pretty sure the precious knowledge that Mr. Joy Mukherjee gave us will definitely help us in our studies and future. We are thankful to Dr. U.B. Desai, Chancellor, Anurag University, Dr. P. Rajeshwar Reddy, Chairman of Anurag, MLC and Chairman, Telangana Raitu Bandhu Samiti, S. Neelima, CEO, Anurag University, Professor S. Ramachandram, Vice Chancellor, Anurag University, Professor Sayeda Samin Fatima, Registrar and HOD of Department of AI, Anurag University, and Dr. G. Vishnumurthy, Dean School of Engineering, for their support from the backend, without which we were not able to do this. Thanks to convener Dr. Tilottama Goswami and faculty members for organizing a 2021 webinar series. Many thanks to student volunteers from the video conferencing committee, program committee, and creative committee for the successful program execution. And a big thanks to all the students present here for paying your attention and engaging in learning. Thank you. Over to Anushri.
Good evening, sir. We would like to present sir a small token of love and gratitude. Sir, kindly accept this. Thanks once again, sir.
Thank you so much for having me. So, thank you. Thank you, and good luck with all of your future AIR webinars. I think I was just as I was speaking, I was thinking about when I went to engineering school back in Manipal. We did not have opportunities like this to talk about with industry people who had industry experience, right? I think this will help tremendously prepare you as you step into towards the end of your curriculum and start to enter the industry. You'll be much more prepared on what things that you need to invest time and effort in above and beyond what your curriculum actually brings. I mean, what your curriculum includes.
Yeah, sure. Thank you for making a roadmap for the students. And I am also very much sure that the students would have taken this advantage. And this has been recorded with your permission. So the students who couldn't join, they can go to the YouTube channel and get the lecture. They can have the lectures again. Thank you, ma'am. And we can have one group photograph, please. The committee members, you can just switch on your video.
Yes, ma'am.
Vinita, where are you?
I taken the
Okay,
shot, ma'am. I taken the shot.
okay.
Yes, ma'am.
Thank you so much. Thank you, ma'am. Thank you, Joy.
Thank you. Thank
Thank you.
you, Joy. Thank you.